write this over. Again, we're on 21.3 really now, but your homework still has 2. We're doing it for small values, and although these notes say chapter 6, ignore that.
Good afternoon. Izzy Binkowski, please come to the office. Izzy Binkowski to the office, please. Thank you.
So I want one of you guys to tell me, in your own words, what is different about this scientific notation compared to the other kind we already did. Yeah, because you're late. Tom.
On this one, we're making the numbers smaller instead of making them bigger. We're using.
Ooh, now be careful with saying making. We are representing.
We're representing.
Yeah, because we're not really doing anything. We're not really changing anything. Yesterday's notes, 21.3, we started it. We did the key concept. Put that back in. We aren't doing anything to the number. We're just rewriting it. So when I do like 2 times 3, I've now done something. I've multiplied. I've changed. But when I rewrite, you're right. We are representing the really small values. That's why you buy spill-proof coffee mugs. So, any questions on the key concept as it was yesterday? So this is really interesting. Human eyes. You guys know about rods and cones?
No.
So your eye, inside of your eye actually flips things over twice. So when an image goes into your eye, it actually flips it upside down and then it writes itself. And you perceive colors through wavelength. So when we talk about sound waves and light waves, literally everything you perceive, like through your sensories, except for smell, I think that just drifts, it's not really wavy, comes in waves. And depending on how tight or wide the wave is, depends on what it's going to register in your eyes. In your eyes, you have rods and cones that pick up the colors and the different things. So do some research on that if you're interested in it yourself. But what this is saying is the wavelength from... So we talk about a wavelength, it'd be from top to top, like one wave. Or it would be from middle to middle, or like just one wave worth. So the wavelength of ultraviolet light is that. How could we represent that in scientific notation? Once you do that, do the guide. I'll give you a couple seconds. I know this is quick. We'll probably get in the floor today. You have yesterday's notes, right? Sweet. We started diving in. Can't always wait for all you gym and whatever people. You guys were all gym, right? You stragglers.
Yeah, he let us out late, sorry.
Happens. Monica, hit me with the first one.
Can I do both?
Nah, hit me with the first one.
Okay.
You got a lot of people in your class.
4 times 10 to the negative 7.
You don't have a decimal point.
You don't need one.
We don't need a decimal point unless there are any significant values beyond the 4 that are not here. So you could write this if you wanted to, like that. And sometimes you will see it written like that. That 0 doesn't do anything. It's just there hanging out. Because if I put a 0 right in there, it wouldn't do anything. It'd just be hanging out. So, verification for the negative 7? Yeah, it moves it 7 places back. So if I went 7 to the left from here, there's going to end up with 6 zeros. Perfect. And an issue on the next one.
Yeah. 1.000 times 10 to the negative 8.
He can.
Unnecessary, but okay. It's fine. So there should be 3, 6, 7, zeros. Because when you move it 8 places, you only have 7 zeros. Questions on either of those?
No.
Flip to Z back.
We're getting done with this really fast.
Scientific notation is quick. This is part of the whole accelerated 7. Once we get through all the main 7th grade, this is 8th grade content.
Oh.
It is. Like when I'm making my homeworks now, it's in the 8th grade panel of work stuff. So, it's kind of like your skill level, being in this class and signing up for it, being able to work quicker, we should be able to run through this stuff more quickly. the standard middle school student would take a little bit longer, but still it's fairly easy content once you understand powers and multiplication and all those sorts of things. So wavelengths range from 4 tens, hundreds, thousands, 10,000s.
4 times 10 to the negative 7.
Well, I know, but I'm trying to see how to say it. Tens, hundreds, thousands, 10,000s, 100,000s, millions. 4 10,000,000ths to, I think this is even smaller, to 700 millions. 700 millions. Well, of a meter, though. See, a meter starts this big. Divide that into a million pieces. And then take 7.
Oh, that's not that bad.
That's
Okay.
not that bad. So, which unit, a nanometer or a meter, might be more appropriate to say this? Because right now we're saying these wavelengths in a unit of meters, so we're registering this number compared to this. And to me, okay, that's, no, yeah, this is meter stick. For a second I got scared of the yard stick. To me that seems dumb, because I'm pretty sure the waves coming into my eye do not have any length close to this. We're talking about 10 millionths and 100 millionths.
Nanometer.
What do you think, Jeremiah?
I think a nanometer would be easier because it's easier to go up than it is to go down.
So the nanometer is a billionth, though. We gotta figure out how we're gonna figure out how many billions these are. What's another way that you could say 40?
4 times
4 tens, right? So we, instead of, how do we call this? We said this was 400 millions. What if I rewrite this number now as, hold up. So actually, go ahead and do this with me. Over here to the left. What if we rewrote this as 0.000040, like we had written on the front? That extra 0 there hanging out. Now I could, instead of calling this 4 10 millionths, let me check that. Tens, 100,000s, 10,000s, 100,000s, millions, 10 millions. Yeah, 4 10 millionths. We could now call this, you know, that is the 10 millionths spot. But instead of calling it 4 10 millionths, we can call it 4D
millions.
100 millions, because now this spot is the 100 millionths spot. So still, we are not in billionths, though.
Next we go to billions.
So if I add another 0, now this spot
So 400 billions.
is billions. So now, instead of saying 4 10 millionths, or 4 times 10 to the negative 7, we can actually register it using integers. And we could say the wavelength here is 400 nanometers.
Cool.
And that's a lot easier to work with. So I want you to try to take the crazy lot of zeros and a 7 and convert that to nanometers.
Gotcha.
Oh no, there's only 6 zeros.
Yeah.
Sorry, I thought there was one more than that. And therefore, this is just as easy as the other one. So, Sean,
700.
and I forget if we can just abbreviate it NM. You might want to check with Mr. Cabilo on how we abbreviate nanometers.
Can we call it nanos?
I don't think so, because nano gets used in multiple ways. You can have nanoseconds, and all that nano means is prefix.
Nanos like
So what do you think nano, especially if you look at this sentence right here,
Small. Billion.
billion. A nano is a billion. So a nanosecond would be a billionth of a second. A nanomile, that would be kind of dumb, is a billionth of a mile. Huh?
It's like
Deca means
Yeah, deca means 10. Or deci means 10th.
what's like the 1 billion? Like there's deca and deci. There's nano and.
Oh, look it up. I forget. Turn this number back into, actually turn both of these numbers back into
Good
standard form.
afternoon. Please pardon the interruption. Sam Hawthorne, please come to the office. Sam Hawthorne to the office.
Tectonic plates
Hey.
and red blood cells. When I donate blood, I donate double red.
What's that?
They take twice as many red blood cells, actually a little bit more than that. So they take all your blood out, not all your blood out, but they take your blood and they put it in a thing, and then like in that thing it spins it really fast, and the viscosity of the plasma versus the blood cells, it separates, and it literally can separate your blood into the different parts.
That's cool.
And there's more than just that, but it just by a centrifuge, right? Spinning a centrifuge. So then they separate it all out, and there's a little bag hanging there with my plasma that just came out of my body, and they put it back in.
What's the
The plasma, so they can make plasma in a lab. You can make plasma. You cannot make red blood cells. So when I donate blood, I'm not actually donating all of my blood. They take my blood out and then give me part of it back, and they just keep my red blood cells.
plasma look like? Is it red or is it clear?
No, plasma's like kind of a yellowish paper. But they actually mix it with something so it doesn't like clump up or anything. So it gets mixed with a little. This gets really weird, so you might get creeped out. They mix it with this little thing, and I forget what it's called. But when it goes in your bloodstream, it then affects everything. Right? It's going back into your bloodstream. It then makes you kind of feel like you're smelling metal. Like for a moment when they're injecting it, that like
Oh yeah, your blood smells like metal.
well, like your blood is everywhere, right? So my blood goes through my nose. So it affects what I think I'm smelling, but it's totally not. I'm not smelling anything. It's in my blood.
That's
When
weird.
you get cut, it smells like cut.
That's cool, but that's weird.
You can
Yeah,
make
I
plasma
never
in
thought
a
about that.
microwave.
You
I've
never,
never smelled
you never
it.
realized
So-
microwave is
Great.
Ashley, in standard form. So I'm guessing because we're working with negative exponents, I'm starting with 0 point. But then what do I have? You just give me the digits. It doesn't matter.
0, 1, 2, 3.
So now, with the whole I don't know how to say it, we name it at its last decimal place. So this is 123, but this place, tenths, hundredths, thousandths, 10,000. So that would be 123 10,000ths if you wanted to say it in standard form. I already called him multiple times today. Oh, we already spoke.
Me?
Unless you really want to. Yeah.
We have already spoken?
Yeah, I called him. Unless, do you want to do the red blood cells?
I'm not there yet. I was listening to you talk.
Well, yeah, it's interesting. But sorry, I get off on tangents. We had a teacher in high school. We could like get off on tangents. We'd never get back to class. Like we'd never get back on topic. Julian, give me the red blood cell width.
Okay, 0.0.
I'm gonna change to red. Hold on, 0 point.
0, 0, 0, 0, 0, 7, I think, or is it 1?
That's right. That's what I got.
So this is a great time to talk about the trick. This says move the decimal left 6 places.
Okay, yeah.
However, to get beyond the 7 is one of your places. So if you're working with negative exponents in scientific notation, that's how I always know that I've gotten loud enough in order. If you're working with negative exponents, all you gotta do is go one closer to 0. So instead of -6, -5. And that, oh, forget about the negative. That tells you how many zeros. So this 6 tells me I'm gonna have 5 zeros, then my 7. So if it was a power of 14, like -14, we'd have 13 zeros and then our digit. If it was a power of -27, we'd have how many zeros? 26 of them. Any questions? Yeah.
I use that number as how many numbers are after the decimal point. That's how I.
Yeah, well, so be careful. Because if this was like 7.123 times 10 to the negative 6, your method won't work then. Because then that would be 0.000007123.
Oh yeah.
See what I mean? So be careful thinking that that always would work. It only works when it's a point zero. Okay.
Mr. Hudson, when do we have math testing? I mean,
Next week.
yeah.
We're doing the practice stuff and the tools tomorrow on foundations, and then we'll pick that up in class. And make sure that you guys are completely comfortable before we get to that.
Do we get a different test?
You get a what?
Do we get a different test because we're accelerated?
No, because you're still just what you've covered this year's 7th grade content.
So it should be easier for us.
Arguably, yeah. So, your white blood cells.
That's a thing.
Yeah, so your red blood cells and white blood cells. Your I think your red blood cells carry the oxygen, and your white blood cells fight against like infections and things. So so your cheek cell, right? So if somebody and they'll do this to take your DNA, and you can actually do this. You can order this swab kit thing, and you swab your cheek, and because your skin is when I do this, there's dead skin floating in the air now. So I can swab my cheek. But because your cheek is inside your mouth, your cells are alive enough, it's got your DNA. See, everything has your DNA pretty much. And you send it away to the lab. And then they use that cheek cell to trace back your
They
DNA.
also use your cheek cells because they come off easily.
Yeah. So it's in your mouth, it's protected. This skin is always losing the dead cells. Everything on the outside is dead.
You're hot. Yeah, you saw
Yep. Yep. And when it dries out, it's just dead skin dry. Like leather. So, try this. This gets us working towards doing operations with scientific notation. We want to know how many times as large. So now we're trying to compare sizes. Now all of these numbers right now are in standard form. Let's throw them into scientific notation just to help us out. So this, we have 8.0 if we want, times 10 to the negative. Yep, we've been working with that. Our white blood cells, I guess I'll use green for that, is 1.08 times 10 to the.
-5.
Think about how far your decimal has to move now to get to here. 1, 2, 3, 4, 5.
I was right. Wait, is that what I said? -5?
And your cheek cell, I'm not certain. 6.3 times 10 to the
1, 2,
5.
3, 4.
negative 5. Be careful, make sure you think about the negative. So, which of these cells are closest in size? Andrew?
Cheek and the vocal.
How do you know that?
Because they both are they have the same amount of zeros and there's actually they're closer, but yeah, they're just close.
So while 1 and 6 are kind of far apart, 1 and 8 are further apart, but 6 and 8 are pretty close. But -5 and -6, these are not 6 and 8.
So that makes it way smaller.
One of them has an extra power of 10. So either it's a 10 smaller or it's a 10 bigger by multiplication. So that's why you're right. These are the closest in size. So, Mr. Smith, if we try to fill in a blank cell is about 6 times as large as a white blood cell.
Wait. The red.
So if I did red blood cell divided by cheek, or no, white, red divided by white, that would give me how many times? So if we try that, set up that division, 8.0 times 10 to the -6, 1.08 times 10 to the -5. That will give me, this will be approximately 8 It'll be 7 something. Or like 7.9, honestly.
Oh, so then it's
Times 10. Negative 6 plus. That is to the negative 1.
so it's the G cell. Or wait, I'm confused.
I think. This. So this is smaller. That's so. Let's back up actually before we even do the division. Realize that the bigger or the more negative that your number is, the further you are in the decimal values. So the smaller you are. So this is 8 tenths, hundredths, thousandths, 10,000s, 100,000s, 8 millionths.
So it's
And this is 108. Not millions, but 100,000ths. So these are 100,000ths, whereas these are millionths.
the G cell.
So let's try that. So if you say cheek,
That's not right. That's an E.
I was about to say this. I knew that it wasn't just CHECK because that's check.
Yeah.
So if I hate my E, doesn't always
Is
connect.
it really a C? There's no C.
That's not a C. That's an E.
There's
But
no
my
C.
E's don't lose.
There's no C. It's
Look, I teach math. Okay.
Math isn't spelling.
It's algebra.
Yeah.
That also doesn't really seem right.
Algebra isn't
I know it is right, but just like English language doesn't always seem right. So let's try this.
ELA.
If we're saying the cheek cell's bigger by 6 times, and we set up the division, this value divided by this value, what would happen with their times 10s, Jeremiah?
Wait, what? I was gonna say something else. I was gonna say.
Well, I know, that's why you should be careful raising your hand before I ask the question.
I was saying, well, that is most likely to be that one because if you just did 1 times 6, it'd be 6, so it's pretty close together.
What I was asking. What happens with those?
Oh,
If I set up cheek divided by white,
they stay the same.
what do you mean they
Wait.
stay?
Well, that
What happens to a number divided by
that
itself?
cancels out.
So
The
that
10 would still be there.
becomes this number and this number are identical. They make a 1. There's no 10 there still.
You should probably use a red.
Does that make sense? Because that really becomes 10 to the 0 power, which any number to the 0 power is 1. Does that make sense? So these become 1. The only division that we actually have to do is that. And 6.3 divided by about 1 is about 6. So try B and C on your own if you've not done those yet. Try that. Can't tell exactly who it is.
That's me.
Somebody's got a song stuck in their head. Noah, what do you think? A cheek cell is about blank times as large as a red blood.
10 times because there's an extra power.
Okay, that's a good thought process there. There's an extra power of 10 in one of them. They're off by a power of 10, so we know that there's going to be a 10 involved in the multiplication. And there's a slight variance between the 8 and the 6.3. So if we want to check this out, how this is phrased it's kind of setting up that the cheek cell's bigger. At least that's what they're assuming. So we could set up cheek divided by red.
No, they're not assuming it's big because you can say it's about half as large. You can say it's about half times as large as the regular.
How? Give me math to justify that.
I don't know.
Then why are you saying it like it's fact?
If you put 1/2 right there, it would just be as half as times as large.
Right, but how it's written, they would normally put the bigger one first. I'm not arguing that we couldn't put a fraction there, just we normally talk about the bigger value first. Because we would rather say something is twice as large rather than saying something is half, because then we'd say as big or like twice as small or half, like we don't normally say half times as large. It just doesn't read right. So I know I can't spell the word cheek, but normally this would read with the bigger value first. Okay? So we can also do the math. The 6.3 divided by the 8 actually comes out to be less than 1. So what's 6.3 divided by 8? Someone with a calculator. Dom, see?
8.3 divided by 8. 0.7875.
So about
Then times 10 to the, these can combine. What did we do back in our exponent chapter when we were doing division with values involving exponents? Ellie?
When you have two numbers that are dividing and they have an exponent, you always subtract the exponent.
And what's -5 minus -6 give me? So this now becomes, so Noah, you were close. It's a 7.8, or if we round, it's about 7.9 times as large. So you want to first divide, in scientific notation we call these the base values, and get your new base value, which is not actually, it's the coefficient value, but get this new number, which doesn't have to be scientific notation, then get your 10 power, then figure it out in standard form. Cool? They're grabbing computers or something. And then we really are limited on our options with what we have remaining. A blank cell is about 1.25 times as large as a blank cell. Well, which of these cells were close to each other, and we haven't used it yet? So we said here was cheek. Let's try again. E-E-K. Yay.
Yay!
Except that looks like a C because my E's go too fast. I've always had that issue with teachers. Same.
Same.
Yeah, same.
So, Andrew, you got a thought?
Because cheek, it's going to be cheek cells and white blood cells, but
Now wait, we already used cheek and white,
doesn't matter.
and that was 6. So how could cheek and white then be 1.2?
You said they were. Never mind. It's going to be 1 times as large, so it's maybe cheek and white. No, we don't use that.
And by the way, I didn't say anything. I asked you guys which ones were the
blood
closest,
is
and I let your answer ride.
They were. Like, right. So it's going to be red. We already used cheek and blood, so red, so it's going to be cheek and white. I think it's cheek and white.
or right away.
Which value up here? Let's start here. Which value up here is the smallest?
The one.
Ozzy, how do you know?
Because first of all, there's more zeros than any other blood cell. That's how it is.
Yeah, they're all in scientific notation, and it's the most negative. So that means it's the smallest. So if we use red, it'll come second, right? Because it's smaller. But I'm not saying that we do use red. I'm just saying if we use red, it comes second.
It's white.
We already compared cheek and white, and we know that white is smaller than cheek.
I think it's red and white because it has to be because that's
So
the
like
only-
white first, then red.
No, red.
'Cause red's the
no, yeah,
smallest.
Yeah, white, red. That's
So let's try that.
because it has to be that because we used every other combination.
So if we do white and red, we're going to do the division, white divided by red. So set that up on your paper. The white is 1.08 times 10 to the negative fifth. red is 8 times 10 to the negative 6. We got to do the division of the coefficient values, the 1.08 divided by the 8, which will give us about 1/8. It's real close. And I know 1/8.
135.
Yeah, I know 1/8 is 125, so we get 0.135 times 10 to the negative 5 minus
One
negative 6.
Power. 1 power.
Yeah, first. So that just moves my decimal once,
Yeah, it's the 1.
and I would get 1.35, which will work. I liked your method too. Checking out. Okay, we use that one. We use that one. We use that one. Good method. So on the next homework that is not posted yet, there are a couple questions that ask, and I might post it today. Like, you'll get through 21 and 2 quickly. So if I get a chance during our break session, I'll try to wrap up the next one and post it. But there are questions which say which of these values is smallest, which of these values is biggest. You gotta look at those powers of 10. Okay?
Are we doing the last one?
Just making sure I talked about it before I forgot, because this was a good example for which is the small. So your red blood cells are the smallest cells. Well, compared to red and white, I forget exactly the size of other, like the cells in your plasma and everything. I forget those.
And between like
Ooh, sorry, hold on. Last thought. This is also why when you donate red blood versus whole blood, when you donate just red blood cell, like the double thing that I do, it's a smaller needle because it doesn't need to be as big. When you donate whole blood, it's a butterfly needle. It's like the bigger kind of needle, which is fine because you can donate quickly, be done quickly. But it's a smaller poke in my arm. So because red blood cells are so small, that's okay. Sorry, go ahead.
between white and cheek, since they both have the same exponent, which one would be smaller and bigger?
So then you just compare their initial value, so that like coefficient. So if I'm comparing something that's 1 times 10 to the negative 5th and 6 times 10 to the negative 5th, that 1 and that 6 occupy the same place value. So which is bigger, 1 or 6? 6.
Oh.
So your cheek cells are bigger than your white cells, which we already said right here. Other questions? How many times as long is cell A compared to cell B? So take a moment, set this up. I know some of us have not solved it. So again, if you quickly try to identify here which is the smallest, Whitney, which one of these is the smallest?
The 3 times 10.
Yeah, because the higher or the more negative your power is, the tinier your value is.
Divided by 10 again.
So take your big over your small. What happens when I have 3 divided by 3? You get 1. Times
10 to the 1.
10 to the first, so just 10.
Whoa.
So when the only difference is the power, a 1 power difference is a difference of 10 times, obviously not subtraction. A 2 power difference would be a difference of 100 times. A 3 power difference would be 1,000 times. And so on. Other questions? We have like 8 minutes left. No, we gotta keep rolling. Rolling.
We should play enough time.
That is my favorite game, but
Wait, what is?
not in grade school. By the way, I'm going to publicly apologize right now. I did not realize this. Sorry, it went right down the crack. I did not realize this until I got them back from the copy center. These notes should not be 2 pages, and it hurts my heart that my formatting got goofed up when it saved it to a PDF because you have to send PDFs to the print shop. But you'll notice as you leaf through this, the last page is a lot of blank space. So please try to use it for something if you get the opportunity to do your homework on this or something.
And downright trash.
says something about you. You immediately go to a female pop song when I say blank space.
What does that mean? What does that say about me that I listen to Taylor Swift?
Alright, my new sister-in-law, that's weird to say. My new sister-in-law is a huge Taylor Swift fan.
Yeah, she's pretty sweet.
Now, I do like that Taylor Swift writes all her own music and
She
like,
doesn't
her-
anymore.
I love all
oh, yeah, how she got popular with her own
I
stuff.
liked it better when she was still country.
Yeah, she was better. She was better.
I have a very selective country palette.
You can say I'm proud of a big green track. That's the first country song I ever listened to.
Alright,
Do you remember 12-12-12? That was like my favorite day of
have
like
you heard
my
about,
entire life.
have you heard about Tuesday? The most epic Tuesday ever?
What's that?
I'll just leave you hanging on that. Try to look up the most epic Tuesday ever. Well, I don't know if you'll get it, but if you search like the Tuesday and literally use like the number 2, we'll talk about this at some other point. But there is like an epic Tuesday coming.
22.
So, now when we operate with scientific notation, we already did a little bit of this on the last thing. We did the division. So when we get to that division, it's not going to be very hard to do. The hardest operations with scientific notation are actually add and subtract. The addition and the subtraction with scientific notation is the most difficult part. So we're going to intro this today, give it a little taste, we'll come back to it tomorrow. Okay? So, the arithmetic operations, when you have the same power, this would really, and it would behoove you, benefit, as Miss Pettigrew used that word this morning, this is really 60,000. This is really 20,000. So if you added 60,000 and 20,000, you would not get 800 million. I don't even know if that, but people try to like say, oh, well, I've got 10 to the 4th. 10 to the 4th, I'm going to have 10 to the 8th. No. If you had 60,000 plus 20,000, you'd get
80,000.
80,000.
Oh, so you just have the numbers and not the exponent.
So you add the coefficients as long as
The experiments are the same.
your exponents to 10 are already matching. So here's the trick that Sean's not really paying attention for. If they don't match, we care more about matching the powers than we do about scientific notation. So remember, scientific notation is very strict with that first number being, 1 digit in front of the decimal. But if it doesn't match, move your decimal to make your powers match. And then the math is easy because you just add the first numbers and keep the power of 10 the same. This does not have to be in scientific notation form. It does have to be in a times 10 form, but that first number does not have to be between 1 and 10. We really don't actually care that much about that. We care more about matching the powers. So we'll show you examples with that. And subtraction, same thing. If the powers match, just subtract the first numbers. If you, I guess you always can, but you might get a weird value. We'll look at those other situations. So let's just do a couple examples and get to it. I guess I might. Let's capture. So, I always mess up this name, deuterium, or deuterium. Yeah, something like that. Deuterium and tritium, I know tritium, are hydrogen atoms. So, deuterium contains 1 proton and 1 neutron. Tritium has a mass of 5.0224 times 10 to the negative 24th. What is the difference between the mass of tritium and deuterium? Deuterium. Deuterium. I always screw it up.
Is that not possible because we don't know the weight of the proton and the weight of the neutron?
Oh, don't we?
I don't know.
Your paper. Add to paper.
Where?
Do you need me to walk to your paper and make this really, really bad? So, we first, I do like your thought process though, Jeremiah. We first need to figure out what the heck does deuterium weigh? Because they gave us tritium, but we don't know deuterium. But to know what it weighs, what do we do, Jeremiah? How do we find out what it weighs? Why did you want those masses?
Because we would need to add the mass of the proton and the mass of the neutron to see how much that deuterium guy weighs compared to tritium.
Tritium. That one's easy. It's easier to say. So, yeah, we just add the numbers together. So, do they have the same power of 10? So, carry that first. Just get that out of the way. Then, add your beginning values.
Okay. Subtraction. Add addition.
So, you're going to get around 3.3, but I don't know exactly what it is.
It's 3.3475.
Confirmed 3.3475.
Times 10 to the negative 24th. So we're asked, what's the difference? Which of these is bigger? Anish, what do you think? Which of these is bigger? Tritium or deuterium? So since they both have the same power of 10, to figure out which is bigger, just compare their numbers. So actually, tritium's bigger. So tomorrow, when I don't know, they're starting to move. How much time do I actually have? I have 3 minutes left. I don't know what they're doing. So we need to take deuterium and subtract tritium. Oh, other way around. We need to take tritium and subtract deuterium from it. So take your tritium, 5.0224 times 10 to the negative 24. Minus 3.3475.
Oh, okay. Well.
Take your power of 10 first, because that's the first thing you have to look at. You cannot add or subtract if the powers of 10 don't match. Then this subtraction gets me 1 point something. 1.7? Anyone got it? Come on.
1.6749.
Sweet. There you go. Now we're done.
Confirmed? What, please?
Maybe. Or they all already checked out. Alright, thank you guys. Tomorrow we will be going over air practice type stuff.
I love new schedules. They make the day seem so much better.
Right? Just like mixes things up.
I just like it.
Well, it's because you're used to this being in the morning, and now your brain's kind of like, wait, the day's almost done.
I like it.